Every once in a while, a paper comes along where the title just says it all. And that is absolutely the case with this 2020 paper, An Image is Worth 16 by 16 Words. What a great title, right? It hints at this beautifully simple idea that completely upended how we think about computer vision. But to really get why this was so revolutionary, we've got to start with a much more basic question. I mean, really, stop and think about that for a second. How does a machine look at a bunch of pixels and know that it's looking at a cat? For decades, the answer to that question was pretty much dominated by one single, very specific technology. And that brings us to the old guard, the long-standing king of the hill in computer vision, the convolutional neural network, or as you probably know it, the CNN. So the main idea behind a CNN is actually pretty intuitive. It's designed to work a little bit like our own visual cortex does. It scans an image in layers, right? It starts small, looking for simple things like edges and corners. Then it combines those to find more complex patterns like textures or shapes, until finally it can recognize a whole object. It's a very bottom-up kind of approach. And listen, CNNs were incredibly good at this. For pretty much any task that involved a computer trying to understand a picture, they were the undisputed gold standard, no question. But while CNNs were ruling the world of vision, a completely different kind of model was quietly taking over a whole other part of the AI universe. So now we're going to shift gears, moving from pictures to words, to introduce the other main character in our story today, the transformer. Now, a transformer works in a totally different way than a CNN. Instead of building up from little details, a transformer looks at the entire input, in its case, a whole sentence, all at once. It's built from the ground up to understand context. It knows that when you say, I'm going to the bank to get some cash, the word bank means a money place, not the side of a river, because it's looking at all the other words around it. And by 2020, transformers were so good at this that, in the words of the paper's own authors, they had become the de facto standard for anything involving language. They were the king of text. So you had these two separate kingdoms in AI, right? CNNs for images over here and transformers for language over there. And they stayed separate until this paper came along and just blew up the whole map. This is where the story gets really, really cool. The researchers behind this paper asked this fascinating, almost kind of absurd-sounding question that connected these two completely separate worlds. Just think about that for a second. What if you could take the most powerful language tool ever created, and instead of feeding it words from a book, you just fed it a picture? It sounds like it shouldn't work at all, right? But the way they did it was shockingly simple. Okay, so here's the method, and it is almost deceptively easy. You take a picture, let's say it's a photo of a dog. You chop it up into a grid of little squares or patches. Then you just line those patches up one after the other in a sequence. All of a sudden, the patch with the dog's ear is your first word. The patch with its eye is the second word, and so on. You literally turn the image into a sentence that's made out of tiny pictures. So you feed this image sentence into a standard transformer. It is a wild idea. But the billion-dollar question, of course, is, does it actually work? Can a model that was designed to read Shakespeare learn to see? And the answer was a huge, resounding yes. And that was the crucial breakthrough. For the very first time, someone proved that you didn't need a complex, highly specialized architecture like a CNN to understand images. You could basically throw all that custom-built machinery out the window and just use a standard, off-the-shelf transformer. And not only did it worked incredibly well. The results were, honestly, staggering. The Vision Transformer, or VIT for short, it achieved excellent, state-of-the-art results. It was right up there with the very best CNNs. But the real killer feature is in that last row. It did all of this while being way, way more efficient to train. This wasn't just a win, it was a total knockout. The new method was just as good as the old one, but, and this is a direct quote from the paper, it required substantially fewer computational resources to train. It was cheaper, it was faster, and it was just as effective. A total game changer. And that brings us right back to that brilliant title. Those words that the transformer was reading, each one was just a tiny image patch, only 16 by 16 pixels. Such a simple, elegant, and powerful idea. So you might be thinking, okay, that's a cool academic experiment, but why does it matter so much? Well, let me tell you, this was so much more than that. This single idea sent massive shockwaves through the entire field of AI. Let's just break down how huge this was. First, it completely shattered the decades-long monopoly that CNNs had on computer vision. Boom, gone. Second, it proved that the transformer wasn't just a language thing. It was this incredibly powerful general-purpose architecture that could find patterns in almost anything. But maybe most importantly, it built a bridge between the worlds of vision and language. It created a common framework, and that directly paved the way for the amazing multimodal AI we have today. Systems like DALL-E or Midjourney that can create incredible art from just a simple text prompt. And all of that leaves us with this one really fascinating question for the future. This paper basically taught a computer how to read a brand new kind of book, one that's written in pictures. It really makes you wonder, what kind of stories are they going to be able to write for us next?